Good day, this is Professor Will, CBMD PhD. Today is Saturday, March 27, 2021. It is 6:34 and 17 seconds, a.m. Eastern Standard Time. Today's research, gravitomagnetism. So let's hop to it here. Factoring in gravitomagnetism can do away with dark matter. Models of galactic rotation, curves built of general relativistic framework, could use gravitomagnetism to explain the effects of dark matter. Date March 4, 2021. Source, Springer. Summary. Observations of galactic rotation curves gives one of the strongest lines of evidence, pointing towards the existence of dark matter, a non-baryonic form of matter that makes up an estimated 85% of the matter in the observable universe. Current assessments of galactic rotation curves are based upon a framework of Newtonian accounts of gravity. A new article suggests that if this is substituted with a general relativity-based model, the need to recourse to dark matter is relieved, replaced by the effects of gravitomagnetism. The main role of dark matter has historically been to resolve the disparity between astrophysical observations and current theories of gravity. Put simply, if baryonic matter, the form of matter we see around us every day, which is made up of protons, neutrons, and electrons, is the only form of matter, then there shouldn't be enough gravitational force to prevent galaxies from flying apart. By disregarding general relativistic corrections to Newtonian gravity arising from mass currents, and by neglecting these mass currents, research asserts these models also miss significant modifications to rotational curves. The orbital speeds of visible stars and gas plotted against their radial distance from their galaxy center. This is because of an effect in general relativity, not present in Newton's theory of gravity, frame dragging or length stirring effect. This effect arises when a massive rotating object like a star or a black hole drags the very fabric of space-time along with it, in turn giving rise to a gravitomagnetic field, a new research model for the rotational curves of galaxies, which is in agreement with previous efforts involving general relativity. The research demonstrates that even though the effects of gravitomagnetic fields are weak, factoring them into models alleviates the difference between theories of gravity and observed rotational curves, eliminating the need for dark matter. The theory still needs some development before it is widely accepted, with the author particularly pointing out that the time evolution of galaxies, modeled with this framework, is a complex problem that will require much deeper analysis. Research suggests that all calculations performed with thin galactic disk models, performed up until this point, may have to be recalculated, and the very concept of dark matter itself questioned. Good day, this is Professor Will, CBMD PhD, on Galactic Space Computer Science and Advanced Engineering. This video is strictly made for educational purposes only. Well, hope you enjoyed listening. Until next time, have a great day.